So hello everyone, thank you for being here. Before I start, a few words about me. So hi, I'm Lea. Here's a fun fact you may not know about me. I'm originally from Greece, even though I live in Boston now. And specifically, I grew up in the island of Lesbos, which technically makes me geographically lesbian, probably the first you'll ever meet. I like open source. You might have used some of my work. There's some of my projects. You can find more on my GitHub. I'm an invited expert in the CSS working group, so if you have any questions about like how CSS standards work, even if it's not related to the talk, feel free to come and ask me, that's fine. There's me over there. I've written a book. If you have it with you, I can sign it. It's translated in a few languages. And my day job is doing research at MIT. Specifically, my research is about making web programming more accessible. I work on this language called Mavo, which is released as an open source project. You can use it if you want. You can experiment with it, give us feedback, maybe even contribute. It's about making entire web applications by just writing HTML and CSS. So without further ado, what I wanted to talk to you about today is basically the intersection of SVG and CSS. I think everyone understands the value of SVG when it comes to logos, interactive visualizations, and things like that. But there's a number of small ways that SVG can enhance what CSS can do. SVG is so much more powerful, sometimes in slightly worse syntax, but it's a lot more powerful. It can do so many things that CSS can't dream of yet. So that's what this talk is about. But before I start, I want to get something out of the way, and that's coordinates. Because there's many people, even people that hand code SVG for a while, tend to be confused about how coordinate systems work in SVG. So here I have an SVG that's just dropped into my HTML. Assume that this is inside my body element. And I've given it a width and height of 200. So as you might predict, its width and height is 300 by 200 pixels. And I also have a rectangle that's 100% by 100%, which occupies the entire SVG. Nothing unpredictable there. Let me add a view box. So a view box defines your coordinate system. And notice that now I've defined a view box that's basically half of my width and half of my height, and suddenly, so the rectangle that was sized based on percentages didn't change. It still occupies my entire SVG. My aspect ratio didn't change because it's the same in my view box. But the rectangle I had basically doubled. Because now the unitless numbers are based on the coordinate system I just defined, which is defined by the view box. I could even do crazy things like this, for example. And then if I want this to be half, it's 0.5. Like these numbers, these unitless numbers, are all relative to the view box. Okay, and let's go back to a more normal view box here. So notice that now I've specified a view box that's 100 by 100, which is different than, it defines a different aspect ratio than what my width and height specify. So what happens then? Both the rectangle that's sized 100% by 100% and my rectangle that's sized with unitless numbers, they both occupy the space that I've defined with the view box, and then the rest of the space is just filled by the SVG element. You can see the yellow background I've defined behind it here. And it's just useless space. If I don't specify one of these dimensions, the other one is calculated based on the aspect ratio. Similarly, if I remove the height, it will be calculated based on the aspect ratio, so it will be 300. And if I remove both of them, then the SVG stretches to occupy the entire element. And also, there's very weird behavior if I don't specify any of them. And that behavior is different based on how you use the SVG. In this case, because it's embedded in my HTML, it becomes 300 by 150. But if I was using it in an SVG image, it will actually stretch to occupy the entire area that it needs to, depending on how I'm using it in my CSS. We'll actually take advantage of this later in the talk. So, to recap, the view box defines the coordinate system. It also defines the aspect ratio. There is a property that allows you to override this. We're not going to use it, so I'm not going to stress it very much. And a view box with no width and height makes the SVG scale to fill the entire area. That's what I want you to remember because it will be useful throughout this talk. And now let's go on to some more practical things. So I've often needed to use characters like glyphs from a font as images, whether they were like special Unicode symbols, emojis, just plain characters. And usually what I did was I had to go to Photoshop or Illustrator, insert my character, style it in the way I wanted, and then export it to PNG or something, and then use it in my CSS. Until eventually I realized that I could embed SVGs in my CSS. And I'm sure most of you have seen things like this. This is actually an SVG circle. It paints this red circle that you see over there. But it's kind of awful. You can't really tell that it's a circle just by looking at the code, can you? It's just meaningless characters. And this is how most of us get introduced to data URIs. And sometimes we never learn that data URIs can be more readable than this. Sometimes we learn that we can wrap them in multiple lines by escaping the end of each line, just like, and this applies to every URL. But okay, so now we don't have horizontal scrolling, but it still doesn't make any sense. However, little known fact, when the file you're embedding is a plain text resource, not just SVG, any plain text format, CSV, TSV, TXT files, anything that's plain text, you can actually just dump it in your data URI, and you only need to escape very, very few characters that have special meaning in URLs. The only one I've come across in everyday practice is the hash character. We'll see a case of escaping it soon. But most characters don't actually need to be escaped these days. We might have seen this with like all the characters URL encoded with like percent signs everywhere, and that's still not very readable. But we don't actually need to escape all that. Old IE needed it. Today that we don't have to care about old IE anymore, we don't really need it. So what have we done here? That's just a regular SVG file. I can modify it right in my CSS. I can move the circle here, I can move it up, whatever. I can make the background smaller because it's just a background and it works exactly the same way as any other background. But now you might be thinking, okay, Lea, so you've done all this just to show us a background that's a series of dots? I can do that with radial gradients. Well, yes, but this opens up the entire power of SVG to us, not just circles and rectangles. For example, what about a text element? And now you can't see anything for two reasons. Because by default, the baseline is 0, so the entire character is clipped at the top. So we can define the baseline to be 1em to bring it down. And now you can start seeing this tiny, tiny, tiny a. And I can make it bigger by just specifying a font size. And there we are. Now we have a background that is that is comprised of the A character. And you might be wondering, well, I've never needed to have a background that is the A character. Like, how is this useful? Well, the Unicode table is way more rich than this. What about a background that is a unicorn emoji? Why not? And you might be thinking, okay, well, whatever, I could just export a PNG with the unicorn emoji. Yeah, but can you enter CSS in that PNG? We can actually have a style element in the data URI that is inside our CSS. And then we can do whatever. Let's define an animation in here. And let's give it some rotation. Okay, so we've defined the dance animation. Let's go here and apply it. And let's say infinite. And let's make it alternate so it doesn't just jump to the beginning when it finishes. And that's a bit of a slow dance. Let's make it faster. There you go. So there's a bunch of takeaways. as we already mentioned, you can have multi-line data URIs by escaping each line with a slash. This is very important. Everything will break if you don't include that slash. You can embed SVG in your CSS with data URIs, and most characters don't need to be URL encoded. And you can use these data URIs to create images out of characters. And of course, you have access to everything you can do in SVG. That's just one example. And you can even create animated backgrounds with CSS animations inside the embedded SVG. What can we use this technique for? One very common example that came to mind was, sometimes we want to style block quotes with this fancy quote character that is sort of a background, like a huge quote that's like a background. And usually we do this by carefully positioning pseudo elements or exporting the quote as PNG. Well, we can use this to do it. And there's actually a Unicode character for this fancy quote. And we can style meters with it. And then we usually star rating widgets only give us flexibility of rating either an integer number of stars or at best like half a star. But if in this way, we don't just have access to like half stars, but also any decimal number of stars. Could even be something like, this, and it will still work. I was actually using it earlier in my talk when I showed my book. And you can see how that works. The code there is some ugliness there because we can't yet style meters properly. This is going to be fixed eventually, but brace yourselves for now. It does require a WebKit pseudo element. And for Firefox, it will require a Moz pseudo element that I'm not showing in the slide for the purposes of saving space. But in reality, you would also need another rule for Firefox and another rule for Edge. Thankfully, Edge is going away, so you won't need that one soon. And even worse, there's a lot of repetition here. You have to repeat the data URI twice, one for the semi-transparent version and one for the actual opaque version. Let me show you how that works by changing the star to something else. So let's assume instead of rating in a scale of 1 to 5 stars, you were rating chocolate ice cream, so you wanted to rate it on a scale of 1 to 5 chocolate ice creams. So you saw how the different layers overlap, right? And you might be wondering, why can't I use CSS variables for this? And well done for thinking of CSS variables. CSS variables are awesome, but they can't do this yet. This is the kind of thing we would want to do, right? And after we've done this, we would also want to put the emoji in a variable. And then we could change just that variable with the emoji, and we would have a different background. Unfortunately, we can't do this. And we can't do this for 2 reasons. Firstly, we don't have any concatenation in CSS. You might be thinking, but Lea, I've concatenated strings before in the content attribute. Yes, you have, but that's very specific to the content attribute. It's not. It's defined in the same property definition that specifies what's the syntax for the content attribute. In other places in CSS, putting strings next to each other doesn't concatenate them. Similarly, you can't actually use a var function in the URL function at all. Even if there's no concatenation happening, even if your entire URL function just contains a variable reference, that will still not work. And it will not work because there's special parsing rules to handle unquoted URLs. URL was the first function we got in CSS, starting in CSS 1. And to put it mildly, things were not very rigorously defined back then. So basically, there's a bunch of ugliness and hackiness for browsers to handle this function. And that has the ugly consequence that anything you put inside the URL function is treated as a URL. If you put a var reference inside a URL function, the browser will think you're actually trying to reference a URL that starts with like var, open parenthesis, dash, dash, whatever. And it will try to fetch that URL, and of course it will fail. Thankfully, we are aware of these problems. We recently resolved to solve these problems. The way we plan to solve them is we're going to add a new function that basically does the same thing as URL, but it only accepts quoted URLs, so it doesn't need all the parsing wonkiness. And also, we're going to add a new function for string concatenation that you can use everywhere in CSS. The names for these functions are still under debate. And don't hold your breath for both of these features. The time frame is kind of long to add new things to CSS. But at least, if that's any consolation, a solution is coming. And it will be useful for way more things than just that. In the meantime, one way to reduce duplication when you use these kinds of techniques is preprocessors. They're still useful. In large projects, I actually like to define a large series of functions that generate inline SVGs. My book was written in HTML and CSS, and actually the CSS was basically Sass, and there are so many functions generating SVG in there. The base one would be like an inline SVG function. This is a sort of a simplified version of what I usually have. And it just generates an SVG data URI with all the stuff that you don't want to repeat again and again, like the XML namespace and the data colon image SVG plus XML. It's kind of tedious. And then you can define all sorts of functions, one for rectangles, one for circles, one for paths, one for emojis. Why not? And then the code I showed you earlier for the meter could be simplified like this. One thing we can use CSS variables in today is for the entire URL. So here, I have a variable holding the entire data URI, and that means I can create multiple layers of it without having to repeat this entire URI, which is kind of a long thing. And let's give it slightly different positions, maybe. Kind of like that, maybe like this. And imagine how long this code would be if I had to repeat this data URI. And of course, now you can also animate it. And yes, I'm aware that this is not a talk about animations, but come on, animations are awesome. So we can animate background position Y to the different background sizes so that it appears smooth, 5, 3, 10. So let's try that. And then we go here to apply our animation. Snowfall, we called it, I think. Let's say 3 seconds, and we want it infinite. And we don't want this sort of like weird ease timing function, so let's make it linear. And there it is. We can actually make it move horizontally a little bit, because now it doesn't look very natural. That sort of looks more natural. And I mean, we can make it snow in the entire slide. Why not? And since there's a variable holding our snowflake, if we want to change what it's actually snowing, we can just change it in one place and it will just work. For example, instead of a snowfall, let's say we wanna make it raining men. So we choose a man in business suit levitating emoji. Apparently that's a thing. I have no idea what the Unicode Consortium was thinking, but it's a thing. So now it's raining men here. So, fourth takeaway, you can use CSS variables for the entire URL. And here's another one of my favorite use cases, list bullets. And it's one of my favorite use cases because it's such a small thing. It's not fancy, but it's so commonly needed. I'm sure every single one of you has needed to use custom bullets at some point in lists. And what we ended up doing is like list style none, and then like weird pseudo element positioning, and then it often breaks with multi-line text. However, with this technique, you can actually use list style image and have real bullets. Let's have a circle, for example, which is probably the simplest list bullet. I already have a view box of 100 by 100, so let's make the center at 15. Let's make horizontally maybe a little bit higher, and give it a radius of 10. Now that's too small, 20. And then we can give it whatever fill we want, and we have colored bullets. Or, I don't know, whatever color you want. That's sort of like a faded red. But you might be wondering, okay, well, round bullets are not that interesting. But of course, you can have anything in there, so why not have text? And specifically, emojis. Same thing that we showed earlier. And again, a font size. Notice that I can also use attributes, but they have zero specificity, so any CSS will override the attributes. And you can have sad emojis if it's a list about sad things. And you could even have like classes that override each individual item and give it a different bullet. Like I had a slide earlier with like all sad emojis, and then like the last one was sort of happy. So the fifth takeaway is that SVG data URIs can help you create bulletproof custom list bullets. And why do I say bulletproof? Let's add some multi-line text. And you can see that it just works fine. We don't have to do any weird like margin, negative margins, text indents, all this stuff that I'm sure you're traumatized by when you use pseudo elements for custom bullets. It just works. It just works. It's a regular bullet. So take a moment to look at this border. There are 3 reasons why you can't have this border in CSS today, at least without any SVG. So in CSS, we can have dashed borders, but we can't have custom dash lengths and custom dash gap lengths. It's just whatever the browser wants to give us, and if we're happy with that, if we're not happy with that, tough shit. Also, we cannot have borders that are colored by a gradient in CSS. Even though we do have gradients for backgrounds, we can't apply them to borders. And of course, we can't have animations like this that make our dashed borders move. So let me show you how you can use SVG to have any of these things in your HTML. We're going to start from a very plain rectangle. It has a width and height of 100%. Notice that it has no view box. There's a reason for that, and we're going to get to it. And for now, it just has a stroke, like a thin black stroke, and that's it, and no fill. For this first example, I'm going to show you how you can have a custom dashed border that animates in the way we saw, like this marching ants animation that you also see in graphics applications when you select a rectangular area and like you get this dashed border that actually moves. So how are we going to do that? SVG has this wonderful property called stroke dash array, which allows you to specify exactly what your dashed strokes will look like, and it accepts any number of numbers. The first one is your dash length. The second one is your gap length. And if you don't provide a gap length, you can notice that it's the dash length by default. It just repeats. Basically, anything you specify here will repeat infinitely. So you can actually have like another different dash length. And you can have like all sorts of weird Morse code patterns here, although I haven't found many use cases for having more than 2 numbers there. And there is also a stroke dash offset property, which starts from 0. And it controls where your dashed border starts. So notice that now, if I'm incrementing or decrementing this property manually by just like pressing my arrow key here, I actually got the animation I wanted. So all I really need is to automate this animation with CSS animations. And since these are normal CSS properties, I can just animate them with an add keyframes rule. What would my keyframes be? Obviously, I would start from 0, but then what would my ending keyframe be? Notice that I want this to repeat infinitely, so I need to select an ending keyframe that will make it look like it's continuously doing the same movement infinitely. And the number that will give me this effect is any multiple of my dash length plus my gap length. Let me show you how this works. So if I have 0 here, I get this result. My dash is 10 and my gap is 5, so together they're 15. If I put minus 15 here, I get exactly the same visual result because I've done one iteration. It has moved by one dash and one gap. Same with plus 15. Any multiple of 15 works. So I'm going to take advantage of this and apply an animation. So let's add a style element and a keyframers element. Let's call it ants because it's like marching ants. And let's paste this in here. And now let's apply this ants animation. And let's make it infinite. And we're almost there, except notice that you get the easing, the default easing, which is ease, which doesn't make it move smoothly. You can see where each animation, each iteration ends and the next one begins because the default timing function accelerates and then decelerates and accelerates and then decelerates. So we also need to specify linear here. And there we are. You might be wondering, okay, we did this, but this is just an SVG that's in our HTML. I actually wanted to apply this to my HTML elements. Well, I've got you covered there. So we copy what we just wrote. And here we have a div with a class of unicorn. And I have a data URI ready for us here. And let's just paste what we wrote in here. Escape the ends of lines. And there we go. And actually, I can give it any aspect ratio, and it still works. And why is that? That's exactly why I did not specify a view box. Because if you're using an image as a background, and you don't specify a view box or any dimensions, then the SVG will stretch to accommodate the entire background positioning area, and any unitless numbers in it will be treated as pixels. So you get the same stroke width regardless of the proportions of your HTML element, meaning regardless of your actual background positioning area. And the numbers we've specified are actually pixels. They're actually treated as pixels. We would not get the same result if we had a view box. This is one of the few cases where you don't specify a view box. Usually it's good practice to include a view box with everything. So, takeaways. No view box or dimensions lets your SVG background occupy the entire element. Stroke dash array lets you create custom dashed borders. And stroke dash offsets lets you move them and is animatable. Stroke dash array is also animatable. There's lots of cool effects you can do with that. For another example, here we have a thick stroke applied on a rectangle, again with no view box for the same reason. And we're going to apply a gradient to that stroke. Brace yourselves a bit because the syntax in SVG is not very nice for this, but the result is worth it. So SVG got gradients about 15 years before CSS got gradients. So they're a little more clumsy. We had like 15 years to flesh them out for CSS. So for SVG, we define a linear gradient element. We give it an ID so we can reference it. And then the color stops are actual stop elements. And let's say, and we specify the color with the stop color property. And let's give this one the blue we already have, 0AC. And now how do we apply this gradient? As a fill, as a stroke, whatever. With the URL function, believe it or not. So we use the URL function with its ID. I'm not sure if that was brilliant or horrible. You can decide for yourselves. Now, you might be wondering, well, Lea, you've specified a gradient there, and it has 2 stops, but I don't see any gradient. It's still just blue. So in CSS, when you specify 2 colors, they're spaced automatically. So if you specify 2 colors, the first one goes to the beginning, the last one goes to the end. If you have more than 2, they're also equally spaced. However, in SVG, you have to manually specify the offset. And now you have a gradient. Before, we didn't really get a gradient because they were both at 0, which is the default offset. Now we also want to apply it, we want the gradient to be angled. We don't want it to be left to right. We want it to have like a 45-degree angle. How do we do that in SVG? There is a gradient transform attribute, and it accepts an actual transform function, like rotate. And the syntax is slightly different than in CSS, transforms. Again, SVG got transforms from the very beginning in like 1998 or so. So the transform syntax is slightly different. Notice that it doesn't have a unit for one. There were no angles back then, either in CSS or in SVG. So you can't actually add a deg unit after it, which also means you can't use different units. You can't have a turn unit or a radian or anything like that, like in CSS. This is a caveat to keep in mind in general when you're writing transforms for SVG, especially because in some places you get the CSS syntax and in some places you get the SVG syntax. Anytime you're using an attribute in SVG, then it uses the SVG transform syntax. If you're using a property, even if you're applying the property to SVG content, then you're using the CSS syntax. But here we can't use a property, so we have to use an attribute. So this is our gradient stroke. And let's copy it and paste it onto our data URI so we can apply it to HTML content and escape the endings of lines. And now notice that this was still not sufficient. There is something more we need to do. Remember when I mentioned that most characters don't need to be escaped? One common exception to this is the hash character. We actually do need to escape this as %23. And here as well. And now we got our stroke. There's another caveat. It's actually showing its structure as a background. Like, yes, we're treating this as a stroke, but actually, ultimately, it's a background, really, and we can see it going behind our text. But this is something we can easily fix with the padding. And if we want to have both space for our border and an actual padding, we can just say 20 pixels plus 1 ems, for example. You might be wondering, why is our stroke width 40, but our padding is 20? Did anybody notice this? Raise your hand. Cool, some of you noticed this. So actually, in SVG, when you draw strokes, half of the stroke is inside your shape and half of the stroke is outside your shape. And there is no property to control this. There was one added in SVG too, but because browsers were not interested, they took it out. If you do care about such a property, you should complain to the browsers because that's what ultimately controls adoption of things. So in SVG, there is no way to avoid this. Strokes are always drawn half in and half out. It's not like Illustrator where you can press a button and have your stroke on the outside and press a different button and have your stroke all on the inside. So, and it's actually, as we'll see in a later demo, as we'll see, it's actually quite complicated when we really, really need to draw our stroke on the inside. It can get very complicated. But in this case, it's fine if half of it is clipped. We still get a gradient border. It still works fine. So SVG supports gradient strokes, though with an unwieldy syntax. You can apply those to HTML elements via data URIs, as we've already seen. And you need to escape the hash as %23 because it's a reserved character in URLs. You don't actually need to escape every reserved character in URLs. The browser is smart enough to figure out, for example, if you're using a colon, it's not actually a protocol in the middle of the URL. So it's very few. I think it's also the question mark that you need to escape, and that's pretty much it. So, another example of fancy strokes that we could fake with SVG. quite often, there are websites that try to pretend they have this handwritten style and things are sketched, and they want to give this organic design kind of feel to them. And usually we do this by applying like handwritten fonts. But when it comes to borders, it can be quite a pain. You have to usually have like separate files for the border and apply them either with border image or like have fixed dimensions. However, there is a way to do this with SVG, which is what this demo is about. It involves using filters. How many of you have used SVG filters? Very few. Okay. So, filters in SVG are defined by the filter element. Just like gradients, we give them a name, an ID, and we reference them by the ID and the filter property. And notice that now I don't see anything because my filter is empty. So it makes my entire element disappear. Let's add an FE turbulence filter. And it requires a base frequency attribute. Let's say 0.2. So what does FE turbulence do? It uses a certain algorithm to generate a random pattern, which is not very useful by itself, but it will be very useful in combination with other filters. And so it requires a base frequency attribute as a minimum, and you can also use a num octaves attribute to specify how many times this frequency repeats, how many octaves. We're going to use 3. Why are we going to use 3? Just from experimentation. And then we're going to use another filter here, an FE displacement map. And God, I hope I write it correctly. So this filter accepts 2 inputs. But in general, when you're chaining filters one after the other, each filter takes by default, each filter takes the result of the previous filter as an input, which is actually convenient in our case. So we're going to use source graphic as our first input. Source graphic just corresponds to whatever thing we applied the filter on, which is why we just suddenly saw it again. And FE displacement map also supports another input, a second input, but we're not going to specify that because we actually want to use the input of the previous filter as the second input. And then we can specify a scale attribute. So what does FE displacement map does? What it does is kind of a very weird thing. So it accepts a matrix as an image, but it doesn't actually use the image. It doesn't actually display the image in any way. Instead, it uses its second input as a sort of matrix where the red channel specifies how much you're going to move horizontally, how much you're going to move each pixel horizontally, and the green channel specifies how much you're going to move each pixel vertically. It's very, very weird. And the blue channel is ignored completely. So basically, what do we want to make it look like a scribble? We want the pixels to sort of slightly move in slightly semi-random ways, which is why we have this random texture via FE turbulence. And then we're using this texture as an input to FE displacement map to make the pixels of our original image sort of slightly move in semi-random ways. And then we have to specify the scale attribute, which by default is 0, which is why we don't see any movement, because by default, the offsets that we've specified are multiplied by the scale, and by default it's 0, so there are no offsets. But if we increase it, then we're starting to see something there. Now, we have another problem. Remember when I told you earlier that half the stroke is drawn on the inside and half the stroke is drawn on the outside? Now it's actually becoming a problem for us. And when it's an SVG that's just directly embedded in our HTML, there are simpler ways around it. We can just say overflow visible, and there is our scribbled rectangle. I promised you it would look like that. However, Overflow visible will not help us when we use this as a background image, because the stuff that's outside the SVG area will just be clipped. So we have to find a different way to do it. And there is where the ugliness starts. So in Chrome, we can specify X and Y attributes to offset it a little bit. Come on, Lea, learn to type. And then we can make the width and height a little bit smaller, because Chrome allows us to use calc in here. So we can say calc 100% minus 6, and here also minus 6, and now we have our whole rectangle. And this will actually work as a background. However, this will not work in Firefox. Firefox hasn't caught up yet, and it doesn't allow us to use calc and fancy things like that in width and height. Instead, to support Firefox, we have to do this horrible thing, which I'm not going to type for you because I want to forget this exists. But if you need to support Firefox, if you really need this squiggly effect to appear in Firefox, you have to actually make the rectangle yourself from lines. And why from lines? Why can't you use a path or something? Because you can't use percentages in paths, and we actually really need percentages here. So we have lines sized in percentages with transforms to offset them. Yeah. So for the rest of it, I'm going to use the calc technique, because it's shorter and because eventually Firefox is going to catch up. So we have our squiggly rectangle. Let's try to apply it to HTML now. Again, the same div with a class of unicorn. Again, we paste it in here. We escape the lines. And we escape any hashes. Where are they? There we are. Yay. And we also give it a padding. Thank you. So let's give it a padding. Maybe too much. Okay, so now what else can we do with this? To recap before we move forwards, so you can use calc and geometry attributes, but not in Firefox yet. FE turbulence creates a pseudo-random texture. FE displacement map shifts pixels around based on the pixel values of another image, and together they can be used to create a scribble effect, as we saw. How many of you have heard of Squiggle Vision? Only one. Okay, so to be fair, I hadn't heard of the word Squiggle Vision before I made this talk. I had to research what is this effect actually called. That resulted in many weird Google searches. I hope nobody gets a hold of my history. So the effect I was looking for was basically this, that I'm sure you've all seen in cartoons, where something is basically supposed to be stationary, but it has this effect of like multiple frames that are drawn separately being infinitely circling between all these frames. So how could we do this effect? Could we apply this effect on our divs? Like we've already done the scribble for our borders, but what if we want the scribble to actually animate like this? Could we do that? Let's try. So here is the rectangle here's the scribble we've already created, and there is another parameter of the FE turbulence filter that I haven't mentioned, and it's called seed. Seed starts from 0, and it just seeds the random number generator, but it could be anything. Like, you could seed it with any number you want. And notice that if I manually increase the seed, then we do sort of get Squiggle Vision, don't we? We just need to automate this. What I'm doing here by incrementing the seed, I just need to automate it with an animation. So my first attempt that I'm not going to show you was trying to use a keyframes animation and hoping that seed has also become a property. But no, none of these filter attributes have been ported into properties. We're currently in a sort of transitional phase that browsers are porting more and more of SVG attributes as CSS properties, so we can animate them with CSS animations. But for these filter parameters, we're not there yet. So we need to use the slightly older way of animating SVG stuff, which is still supported pretty much everywhere. It's called Smile. Again, this is a running theme. It's kind of ugly, but powerful. So the way Smile works is you nest an animate element inside the thing you want to animate. And then you specify a duration, let's say 1 second, and an attribute name, which in our case is seed, and values, which in our case is, let's say, 1 to 10. And then a repeat count, which should be indefinite. Is it? What did I do here? Come on, don't fail me. Yeah, it should be a colon. And I guess nobody has seen Smile before, so can spot what I did wrong here, right? I think it's the duration, but God. No, it's not. That's actually a point I wanted to make, that for some reason it's indefinite and not infinite in Smile. Well. Should I? Well, I shouldn't spend too long trying to debug this. What?
I have coded something with from and to. From minus 100 to.
No, values should work. Actually, you know what? Just close your eyes here for a bit. Semicolon. Yeah, in retrospect, maybe I should have just said, let's pretend this works and move on. But yeah, I really didn't want to, because I love this effect and I wanted to share it. So yeah, semicolon, not colon. So let's apply this to our HTML element. Here's what we've done previously. And I guess we don't actually need to go and escape everything again. We can just copy this. That's the only change we made, really. So let's go here, insert a new line, escape that line, and paste this. So you can see that now we got Squiggle Vision for the border. And it's animating, and I hope you can see it from the back animating as well, right? Can you? Okay, good. So, yes. So you cannot animate filter parameters with CSS animations, but you can use Smile. And animating the seed of an FV turbulence filter creates Squiggle Vision. Are we done yet? No. So after I got this working, I was thinking, you know what? This doesn't look like proper Squiggle Vision. The border is animating, but the text is not. So how could I also make the text animate to make it look like proper Squiggle Vision? One way to do that would be to actually move the border from the SVG to an HTML border, to a CSS border, and then apply an SVG filter to the whole thing. You can apply SVG filters to HTML content, so that should work, right? So what I tried was something like this. And then I removed the rectangle from here. And instead, I changed the background with a filter, and I added a hash here for scribble. And notice what happens. It's not that it completely doesn't work. It is actually applied, but it's not animating. Do you see this? Let me tweak it on and off. Now it's not there. Now it is. Now it's not there. Now it is. You can see that it's applied to everything, but it's not animating. For some reason, in Chrome, if I specify a filter via URL, it doesn't seem to support animation in the filter. I'm not sure why, but do not give up, because there is a workaround. So, if you actually include the SVG, if you actually embed the SVG in your HTML, and let's actually copy it from where? From here, that's better. Where were we? Now let's go here and paste the SVG here. And hide it with display none. And actually, will this work? Yes. So basically, we pasted the SVG here. We don't actually need the rectangle anymore. We just need the filter. It still has the same ID. And we don't need a URL here anymore because it's actually local now. And now we got Squiggle Vision. And let's specify some padding too to make it look nicer. Thank you. So I think now we are pretty much done. To recap, if you use a data URI in the filter property, animation is disabled in the filter. It's probably a browser bug. And including the filter in your HTML can fix that. And you can actually hide the filter. You don't need the SVG. You don't need to display the SVG in any way. It's just a little bit of ugliness in your HTML. You can pretend it's not there. So this is actually what I used in the cover of this presentation. If you look at the heading, where it says the web design cheat code, it actually has that applied to it. So I hope that was useful. Thank you very much. I also have stickers. Come find me.
I love how you said, don't give up. As if any of us would have got 1% as far as you did with that. That was absolutely incredible. I've spent most of that in shock and not really like just going, oh, that's amazing. The interwebs has once again given us some questions, both from in the room and remote. So if you don't mind, I'm going to ask you some of them.
Sure.
The top one, I'm going to read it in what I imagine the voice is of the person who wrote it, but only because it sounds very indignant, and that's, and what about Internet Explorer?
Well, if you look at the market share of Internet Explorer, it's actually extremely small at this point. Even IE 11, like even if you combine all the IEs up to IE 11, it's like 1 or 2%. And if you design things properly with graceful degradation, progressive enhancement, like ultimately these are all visual effects. If they're not there, a website will just look less pretty. It won't break. Like you have to do something very wrong to actually break a website because Squiggle Vision is not animating. Or because the border doesn't have a gradient.
Can we all say Squiggle Vision more? That's literally the best word I've ever heard. Should we all say it together? Shall we all say it together on 3? 1, 2, 3.
Squiggle Vision.
Amazing. Sorry, I'm just going to freak out at that. Right, next ones. Will the slides be available after the talk? And
look at the URL.
Easy tiger, easy unicorn, I should say. And what software did you use to make them? Everyone seems to be very interested in that.
Also,
If
on the last slide.
If I had read the screen, I would have known that.
It's also something I wrote, but it's in a separate repo on GitHub.
Amazing, right, okay, let's all go immediately use that. And we've got a slightly combative one, I feel. Once CSS Houdini can be used, will there even be a point for SVG? She's sitting down for this one, it's going to be big.
I believe I believe we will be able to use Houdini specs pretty soon because browsers are very, very interested in them. I still think there's value in SVG. First off, not everybody can write JavaScript. So even with Houdini specs, you're stuck using other people's effects unless you can write JavaScript yourself. And not every single colleague of ours can write JavaScript. There are many designers or front-end developers that just focus on HTML and CSS, and they cannot write JavaScript easily. And actually, and it's not even like super trivial cases. Like writing JavaScript to define a new sort of visual effect via Houdini is not something like someone can do that just knows like super basic JavaScript either. So I think there's still value for declarative languages like SVG. It's a different paradigm, and it's actually part of my day job is studying these people that don't write backend code or JavaScript, but they are proficient with HTML and CSS. Like my entire research is about enabling them to do more with HTML and CSS. And there's a lot of these people, they're very capable, but like JavaScript, imperative programming is not for everyone. It's not something that is easy for everyone. So I think there's always going to be space for declarative languages like SVG. Just because you can't always expect someone else to write the effect you want, you can just write it yourself in SVG, and often with much less code.
Thank you for that succinct answer. Thank you. We've got a couple more. We've got 2 more minutes, so I think 2 more questions. Oh no, somebody just put another question on. There was 2 questions there. You've ruined it for me. How heavy are these animations on the processor and battery?
So it depends on the animation. The Squiggle Vision one is kind of heavy. The rest are okay. The rest are pretty performant.
I know if that was a pause for water or dramatic pause or not there. That's why I was waiting. And is it possible to apply anti-aliasing in SVG filters?
I'm not sure how. If you discover how, please tell me as well, because I also don't like the aliasing there. But when I looked into it, I couldn't figure it out.
Wow, that's really amazing. That's all amazing. Can we have another round of applause for Lea there? And also, Amy, you're overly keen, you are. It's always been your problem, that is. Yeah, too keen. Lea, Front-End United somehow found out that you were pregnant. I don't know how. I don't know how. So we would love to give you a little present. So here you go. And if you would care to unfurl it for the crowd.
Oh my God. This is the cutest thing ever.